Okay, the digestive system can be simply summed up with four things, and they are, as we look over here, ingest, that means taking in the food. Digest, that means taking that food and breaking it into its smaller components. And then absorption, which is going to be after you break down everything in your small intestines, you are then absorbing it into your body. And then the last one is elimination. So you got ingest, digest, assimilate, and eliminate is the easiest way to remember it. And that's going to be getting rid of anything that you didn't use for energy and eliminating it as indigestible remains. Here is a overview of every place that we're talking about. So the mouth and the oral cavity is where we were also talking about when we did the respiratory system, because at the beginning they overlap tremendously. And then I'll go through every one of these, and then we're going to go down this tube. This tube is posterior to the trachea, which they don't even show on this picture. And that's going to allow the food to go from the mouth past the hyoid bone and the epiglottis. And of course, if you remember, the epiglottis is the switching mechanism to make sure that food goes down the right tube. So if I were to ask you in a quiz, which I normally do in a regular class, who has the right of way, food or air? Everybody traditionally says air because it sounds like it's more important. But technically, food has the right of way, and the epiglottis is going to ensure that food goes down the esophagus and into your stomach. The stomach is going to be that organ where, when it's not mixing it up, we'll store food for a period of time. And then from it, we're going to go from the stomach to the small intestines, which consists of the duodenum, the jejunum, and the ileum. And that's all of this gut stuff here. And then we're going to go into this thing that makes a picture frame around all of your small intestines. It's going to start with the cecum. This is the large intestine, and then it was named according to what it does. From there, it's going to go up. That's called the ascending colon. Then we're going to make a bend here at the liver. That's going to then go across country from one side to the other. And the bend here is the right colic flexure, or it's called the hepatic flexure. When we finally bring our food all the way over to the left side, the bend here is then going to go downstream, which is the descending colon, and it's right here at the spleen that you can just see, and it's called the splenic flexure or the left colic flexure. And then as the food residue kind of works its way, there's an S-shaped one here that's called the sigmoid colon. Finally, it'll reach the rectum, and then finally the anal canal in the anus, and that's it. Your job for the digestive system is to make poop. And I'll explain all of them and all of the parts that we're talking about as we go through them. So the easiest way to do this is just kind of go over where it starts. So the mouth and the associated organs are going to be involved with the process of digestion of food. So the associated organs up in the mouth area are going to be the tongue, the salivary glands, and the teeth, and they're all kind of like all of the parts in the respiratory system. They're going to play a major role. So the mouth is also called the oral or buccal cavity. We're not even going to go over it, but it's bounded anteriorly by your lips, the cheeks on either side, the hard palate superiorly, and the tongue inferiorly. And basically, because it's food, it is going to be like the esophagus lined with stratified squamous epithelium. The lips themselves are nothing more than a muscle. They are the orbicularis oris, if you want to flash back to AMP1, and that's where you're going to put food into your mouth. When you look at this mid-sagittal view here, you'll kind of see a few things. Here is the mouth and the tongue in cross-section. You can kind of see it's all made up of skeletal muscles, and they play a major, major role in manipulating your food as it goes into your mouth, because you're going to sometimes not want to chew food, and I'm just going to use pudding as an example. You're just going to push your tongue against either the hard palate or your teeth or something like that. So it plays a major role in manipulating your food. If you remember back to the respiratory system, here is going to be the nasal cavity, and as air comes back here, it's going to go down the back of your throat and then down into your trachea. But if it's food this time, because we're talking about the digestive tract, if you remember, two things happen when you have food in your mouth. One, the uvula will rise reflexively to close off this nasopharynx. Secondarily, as soon as food touches this thing here, it bends in half to close off the tracheal inlet. So those two things happen without you even thinking about it as soon as anything touches the epiglottis. And it could just be a drop of water. It's going to make it close so it doesn't go down the wrong pipe, and it will go down the back tube, which is the esophagus. The palate itself, as I mentioned before, is going to form the roof of your mouth, and it has two distinct parts. One is going to be the hard palate, which is made up of the palatine bone and the palatine process of the maxillary bone. And if you've ever run your tongue over the top of the roof of your mouth, you'll feel that it's slightly corrugated. So that also, like all the things that we talked about with the respiratory system, has a purpose. Its main purpose is to create friction against the tongue so that you can chew pudding or jello or something like that. The soft palate is going to be posterior to the hard palate. It is going to be mostly made of a skeletal muscle and of course skin over the top of it. Its purpose, as you can see here in the second line, is to close off the nasopharynx during swallowing. In addition to the soft palate, at the end of the soft palate, there is something called the uvula. It is a finger-like projection that faces downward from the free edge of the soft palate. And when I was a kid, I always thought it was a punching bag at the back of your throat. So as you look at this one here, which is the open mouth, here up here is the soft palate, here is the hard palate. These are where you could still feel the bone, and then after this is going to be the soft palate, and at the center line there is this punching bag thing that's called the uvula. So the uvula and the soft palate will rise reflexively to close off the nasopharynx. The tongue, which is shown here really, really well, is going to be anchored to your floor of your mouth by the lingual frenulum. That's kind of interesting because if you have the lingual frenulum too tight, the word that they usually give to you is that you're tongue-tied. And if you ever tried to talk without moving your tongue, that's kind of a good example of what could happen. So if you have a child, usually that's when they'll do it, they'll just kind of snip this lingual frenulum just so you can have your tongue loose so it's not stuck to the bottom of your mouth. This one actually does show you the teeth that I'll get to in a few minutes, but there are a lot of other things that are going to happen in your mouth. Remember, you're going to have air going into your mouth. You're also going to have food going into your mouth. And if you look here in the back here is the palatine tonsils. So because there's bacteria on food, you want to have those tonsillar tissues exposed to it as soon as you can so that you can kill off the bacteria. The tongue itself consists of two basic muscles. One is going to be the intrinsic muscles. They are going to have the purpose of changing the shape of your tongue. So if you could roll your tongue and curl your tongue and stuff like that, those are the intrinsic muscles that will allow you to do that. The extrinsic muscles are going to alter the shape or alter the tongue's position. So if you stick your tongue out at someone, it is one of those extrinsic muscles that are going to allow you to push it out and also move it from side to side. So the purpose of a tongue is to grip, reposition, and mix food during chewing. The formation of saliva and the food is called a bolus. The bolus is a mixture of food and saliva, and it's going to then go into the next area, which is going to be the esophagus, which will go into your stomach. So on the surface of your tongue, if we were dissecting a cat, that's a perfect example of it. You're going to have a whole bunch of things on the surface of your tongue. Now all they do is point to something like a dot here. But when you dissect a cat, the filiform papilla truly look like the barbs of a Velcro. So when a cat cleans its fur all the time and they end up having a fur ball in their stomach, it is due to the fact that some of these, that they're just showing as a round circle, are going to be hook-like so that they can groom themselves. In a human, since we don't usually groom ourselves with our tongue, the only purpose that you can find for the filiform papilla is when your ice cream cone is dripping and you look at it so it doesn't drip onto your lap, and you have your tongue go all the way around from side to side, you'll see little grooves in the ice cream of the ice cream cone. So everyone else besides the filiform papilla are just going to be taste buds, like the fungiform papilla, and also the vallet papilla, which make a V at the back of your tongue, and also the folate papilla, which are along the side of your tongue. They're all designed to make sure that you can taste the food. At the back of your tongue, if you look at all of these bumps here, they are not papilla, they are actual tonsillar tissue. So they're called the lingual tonsils. And so when food gets to the back there, that is the last thing as food, before it goes into your stomach, that the food is going to have to brush against, and they can kill off any bacteria. So the lingual tonsils are actively involved with making sure that you can kill off any bacteria if it gets into your stomach. The last thing I'll point out here is this one that's shaped like a V. It's called the vallet papilla. That's the way that I always remembered it, and it's going to have a separation from the anterior portion of the tongue, and then there's a space. The space is called the terminal sulcus, and then posterior to the terminal sulcus will be the lingual tonsils. So the tongue itself doesn't look like much of anything, but it's going to try and manipulate your food so that you can form a bolus. It depends on the food that you're eating. So you're going to have to mix it with saliva. So you're going to twist your tongue so that it's pushing against your teeth, the roof of your mouth, and also mixing the saliva and the food together so that you can then swallow it. Just something showing you the papilla, and the filiform papilla gives the tongue its roughness to provide friction. It's the only one that does not contain taste buds. Everything else is going to have a taste bud, so that's the foliate. The circumvallet papilla, which is also called the vallet papilla, and then the fungiform papilla, which are going to be the thing that most people would see on the top of their tongue, kind of like a reddish hue to your tongue. The terminal sulcus, like I said, is the groove that's located posterior to the vallet papilla, and it marks the division between the body of the tongue that rests in the oral cavity and the posterior aspect, which is going to go into the oropharynx. Here is this particular book explains that being tongue-tied, the actual condition is called ankyloglossia. It's a condition in which the children are born with an extremely short lingual frenulum. And as I mentioned, if you can't move your tongue around, you can't articulate and talk well. And so what they usually do is they snip it at birth. So the next thing we come up to is saliva. Saliva has two purposes, if you want to think of it that way. One, it's going to cleanse your mouth. It's also going to begin the breakdown of starches with something called salivary amylase. So the breakdown of carbohydrates like crackers and stuff starts in your oral cavity even before it gets to your stomach. In addition to that, it's going to help dissolve food chemicals so that you can taste things, and it will moisten food to make that's something called the bolus. So you need saliva and whatever food you're eating so that it can go down your esophagus and get into your stomach. Most of the time, you're going to have food or water in your mouth or saliva in your mouth, and they're going to be produced by the minor salivary glands that are in your mouth that are keeping your mouth moist all the time. There are going to be three major extrinsic salivary glands, and let me just show you where they are. This one here that's anterior to the ear is called the parotid gland, and you can kind of see the green tributary. Its saliva comes out up at your molars. Then there's going to be two under your tongue. So here is your tongue. Underneath your tongue is the sublingual gland. And so this one and one that's below it, which is going to be in your mandible, which is called the submandibular gland, are going to be activated when you put food in your mouth, because creation of saliva is through pressoreceptors. So for any of you who ever had to wear braces and you had braces on a whole bunch of teeth, just having that hardware in your mouth can cause you to have a squirt coming out of either the sublingual or the submandibular gland. So their job is to create saliva so that you can moisten the food to allow you to swallow it. Salivary glands have two types. One are serous, which is kind of watery. The other is mucus, which is kind of producing mucus ones. And so that's going to be mixed together along with your food so that you can swallow it. If you see this composition of saliva is basically 97 to 99.5% water. It is slightly acidic. A lot of things in your body need to be slightly acidic. First of all, to destroy any bacteria that might come in contact with your mouth. Teeth are the next thing that we're going to talk about. We haven't even left the mouth yet. So the teeth are basically lying in a socket in your mandible and your maxillary bone. And we're just going to deal with the adult teeth. So these are deciduous or milk teeth or the baby teeth. These are the ones that are going to get pushed out by these here. These here have pretty much 2 or 3 groupings. The first 4 teeth, 1, 2, 3, 4, are called the incisors. This is the central. Then as you get out from these two, the 2 lateral ones are called the lateral incisors. One of the interesting things to look at, when do you first start losing your teeth, or when do you first start getting your teeth? The baby teeth start coming in around 6 or 7, and that is the first molars. And then, you may not remember this, you'll start getting around 7 and then 8, and then it'll work its way down 9, 10, 11, canine, premolars or bicuspids, and then finally at about the early teens, late 12, will be the second molar. And some of you may or may not even have your wisdom teeth. Most of the time, they will pull the wisdom teeth because it may interfere with the other eruptions of the other teeth. And you don't get them until 17th to about 25. So the adult teeth will push the baby teeth out of the way. The function of these teeth are important too. The first 4 teeth, 1, 2, 3, 4, are the incisors. These guys are like chisel shaped. Usually they're for biting or nipping into food and for pulling off bottle caps. I don't suggest you do that. The second ones, so here's 1, 2, 3, 4 on a baby, 1, 2, 3, 4. The next ones are called the canine teeth. Please note how canine is spelled. It is not spelled K-9. So canine are also known as your eye teeth. In the real world, you'll use them to open bags of chips. And then what will happen is all the ones that work their way towards the back are the grinders. So the premolars, the bicuspids, the molars, and then, third, second, and first molars and the premolars are all going to be involved with grinders. So you have the chisel-shaped ones, the eye teeth, which are going to be pointy, and then you'll work your way to these are a lot bigger and flatter so that the surface area will allow you for grinding. Okay, that's 1. We'll go to 2. So we got the food in our mouth, we chewed it, we got it moist with the salivary glands, saliva, we made a bolus, and then once it gets to the back of our throat, it is going to go from your oral cavity into your oropharynx and then into the laryngopharynx. Remember what I said in the lecture on how to know what the pharynx is made of histologically? Anytime food touches it, it's going to be stratified squamous epithelium. So this portion of the pharynx is going to have both food and air going down it. So the oropharynx and the laryngopharynx is lined with stratified squamous epithelium. And as the flattened tube that goes from your mouth into your stomach, it's called the esophagus. The esophagus, because it has food going through it, is lined with stratified squamous epithelium. Where the esophagus pierces the diaphragm, it's called the esophageal hiatus, and where it joins at the stomach, it's called the cardinal orifice. Now let me just show you what that looks like here. Okay. All of these glands, or all of these organs that I'm going to talk about, are going to start with a sphincter, and they're going to end with a sphincter. So for example, the esophagus comes down and ends at the gastroesophageal sphincter, which is also called the cardiac sphincter. So if you look at this top layer here, this is a bolus of food. It's green. So as this person is swallowing it, as the food goes to the back of their tongue, two things are going to happen. One, this part that's hanging down, which is the uvula, is going to rise reflexively to close off the nasopharynx so the food doesn't come up and out your nose. The second thing that's going to happen, if you look at the epiglottis here, it's standing upright. As soon as it gets touched, and so the beginning of the food as it touches it, it bends it over so that it flexes because it's made of elastic cartilage. So that means it's closing up the trachea, and so food has the right of way, and so it's going to not go into your lungs, it's going to go down this back tube here, and that's called the esophagus. One of the things I want you to notice here, as the food goes down the esophagus, as soon as it goes down, it closes the muscles really tightly. So as the food drops down, it's going to stretch it a little bit. Here's the bolus of food here, and then eventually will, as it gets from here and goes to here, you can see the green stuff getting and opening up the sphincter, or opening up the sphincter eventually, but opening up the muscles that are making up the esophagus. As soon as the food gets down to the end of the esophagus, it gets to the first valve or sphincter, and you can kind of see here, because as it's gone from it being closed, it's now, as food goes through it, it's going to dump into your stomach. At that particular point, the bolus of food, whatever the food was, has gone through the gastroesophageal sphincter and is now going to go into the stomach itself, and that's where a lot of digestive processes are going to take place. The stomach is just nothing more than a temporary storage tank that starts the beginning of protein digestion, and an empty stomach only has about 50 milliliters of volume, but it can stretch up to about 4 liters. That's incredible if you think about it. Now, I don't know if you watched it, but every 4th of July, I always watch the hot dog eating contest, and those guys in 10 minutes will eat 74 hot dogs and the buns. So the stomach itself has an incredible ability to stretch to accommodate the volume. And so I'm just going to go right to the anatomy of it. So they don't even show it, but here's the esophagus going to the cardia portion of it. There should be shown here the sphincter there, which would be the gastroesophageal sphincter, because remember, all of these organs